cubical box of 0.6 meter on its edge, has its base horizontal and is half filled with a liquid, the specific gravity of which is 1.5. The remainder of the box is filled with oil of specific gravity 0.9. One of the sides is held in position by means of 4 screws, one at each corner. Find the tension in each screw due to the pressure of the liquids. So let's analyze the situation by figuring it out, the given condition here. So this is the box, cubical box, 0.6 meter on each side, so 0.6, half filled with liquid of specific gravity 1.5. The remainder is oil of specific gravity 0.9. And one of the sides is held in position by means of 4 screws, so 2 at the top, 2 at the bottom. So let's imagine we analyze this side here. So this is the pressure diagram due to oil, then extend, then this is due to this liquid of specific gravity 1.5. So we will call that P1. This one is P2 due to this liquid here. Then we have F1 due to the volume of this pressure diagram, F2. By the way, this distance is 2/3 of 0.3, so 0.2 meter. This is F2. This is rectangular pressure diagram, so its location from the top is 0.15 plus half of 0.3, 0.15 plus 0.3, 0.45 from the top. So it is 0.15 meter from the bottom. Then F3, this triangular pressure diagram, 1/3 of 0.3 is 0.1 from the bottom, 0.2 plus 0.3, so 0.5 meter from the top. Then the tension in the upper screws, there are 2 screws here, so 2 times tension in the upper screws. Then there are also 2 screws in the bottom, 2 times tension in the bottom screws. So summation of moment about the bottom equals 0 to T sub u times 0.6 equals F1 times 0.4, because 0.2 from the top, so 0.4 from the bottom, plus F2 times 0.15 plus F3 times 0.1. So this is the equation if we sum up moments about the bottom. Then later we will sum up moments about the top. Now F1, let's solve for P1 first to solve for F1. So P1 is specific gravity of oil 0.9 times 9.81 times depth 0.3. So P1 in 9,810, let's express the value of P1 to pascals. The expected tension in the screws will just be newtons. 2648.7 pascals. P sub 2 is specific gravity of pressure at the bottom is P1 plus P2. So let's just concentrate on P2. That's 1.5 times 9.81 times 0.3. So in pascals, 4414.5 pascals. So we can now compute F1, volume of this triangular pressure diagram. It is 1/2 or 0.5 of P1, 2648.7, height 0.3, perpendicular to the board 0.6, because the box is cubical. So 0.6 meter by 0.6 meter by 0.6 meter. So 0.6 meter perpendicular to the screen. So it is 238.4 newtons. F2 on the other hand is P1 times height 0.3, perpendicular to the board 0.6. So 264.7, height 0.3, perpendicular to the board 0.6 meter, for 76.8 newtons. F3 is volume of this triangular pressure diagram, 1/2 or 0.5 of P2, 4414.5, height 0.3, perpendicular to the board 0.6. So it is equal to 397.3 newtons. And we now substitute above. So 23 sub u times 0.6 equals 238.4 times 0.4 plus 476.8 times 0.15 plus 397.3 times 0.1. So T sub u can now be computed. So this is the tension in the upper screws, 172.2. Tension in each screw in the upper part, 172.2 newtons. Then summation moment about the top equals 0 2 T sub B times 0.6 is equal to F1, 238.4 times 0.2 plus F2, 476.8 times 0.45 plus F3, 397.3 times 0.5. So tension in the bottom screw, in its bottom screw is 384.1 newtons. So that's it.